Alright folks, we're back working on our mock EOC corrections. We are going to go through a bunch of problems today for a couple reasons. Let's just look at 25 first. So it asks, what are the rational roots of the function? We pay attention to this rational roots thing. We're going to cover this in 8.3, which is the rational root theorem. So until then, we're just going to say that the answer to number 25 is going to be A. Yay, congratulations. Again, we'll cover this in 8.3. It'll make a lot more sense then. And then you're told that we'll get that right on the EOC. Okay, 26. Log base 2, which is that little number down here, of x is equal to -3, which 9.2, which is the unit right after number 8, is we'll deal with going back and forth between logs and exponential form, and we'll figure out what all that means then. For 9.2 right now, for number 26, we're just going to say that the answer is going to be B, and you will totally be able to get this after you've done 9.2. So that's two problems that you're 100% going to be able to get after we have gone over it. Until then, we're just not going to worry about it. Okay, 27. So here's what I'm looking at. It says triangle ABC. So I'm going to draw a triangle ABC. Measure of ACB is 48 degrees. Measure of AC is 17 feet. CB is 10 feet. Unfortunately, it doesn't tell us that it's a right triangle in any way. So what we can't just go ahead and use is we can't just go ahead and say, hey, this is going to be geometry trig. So when you're looking at it, you can look back at your formula sheet, and I'm looking for something for triangles. So triangles, 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 triangles. Nope. Okay, triangles, triangles. Oh, there's a triangle. Law of sines and cosines. You guys will definitely get the law of sines and cosines, but in pre-cal. If you take maybe CCR?
I'm not totally sure. Regardless though, you won't see this in this school year, and that's fine. Like one of the first units you do if you go into pre-cal, maybe Algebra 1, but definitely pre-cal, is that you'll do a whole lot of trig and you'll do a whole lot of law of sines and cosines. For right now, this is one of those questions that we're going to miss, and that's fine. So number 27, we're going to say A, and that's the whole thing. So if you take pre-cal, this will be one of your first or second units. Otherwise, we're not going to worry about it. Oh wait, 28. Believe it or not, this circle, it says in the unit circle where theta, which is this funky letter here, we pronounce this as theta, is the angle formed by the x-axis and OP. So that says the ray that starts at O and goes through P. What is another way to write the coordinates of P? And they're asking for a definition from trig, which I know is 100% the first unit you're going to do in pre-cal if you go to pre-cal. So this is like pre-cal unit 1 is some more trig stuff, especially the unit circle, which is cool. I love it. I think it's awesome, but it's not worth our time to talk about this right now. So number 28 is going to be A. Congratulations, you get another freebie. This is another one that if you see a question like this in the EOC, it's one of those you shouldn't waste your time on. However, number 29, we have rationalized the denominators. We did this back in Unit 5? Unit 5, with all of our adding and subtracting of radicals and all that stuff. So to rationalize denominators, we have to multiply by the complex, not the complex conjugate, the conjugate, which is the thing on the bottom, except we're going to change the sign in the middle. And what we multiply on the bottom, we have to multiply on the top. So we have a binomial times a binomial. So 4 times 4 is a negative 16. 4 times the negative square root of 2 is negative 4 square root of 2. Square root of 6 times 4 is positive 4 square root of 6. And square root of 6 times negative 2 is negative square root of 6 times 2 is 12. Okay, all divided by 4 times 4 is 16 again. 4 times negative square root of 2 is negative 4 square root of 2. 4 times positive square root of 2 is positive 4 square root of 2. And negative 2 times, or square root of 2 times the square root of negative 2 is negative square root of 4 times, or 2 times 2 is 4. So a couple of these can simplify. We know this is going to equal 0.02. We know that 12 we can rewrite as 4 times 3, so that we can take the square root of 4 and you get 2 square roots of 3. So in the numerator we're going to have 16 minus 4 square roots of 2 plus 4 square roots of 6 minus 2 square roots of 3 from the simplified version of the square root of 12. Now at the denominator, something cool happens when we multiply by our conjugate. Negative 4 square roots of 2 and positive 4 square roots of 2 will cancel, leaving us with 16 minus 2, which is 14 in our denominator. So the bottom equals 14.
So, I see that as answer D. But, there's something funky here. We've got a 2 times 8 is 16, minus 2 times 2 is 4, plus 2 times 2 is 4, minus 2 square root of 3, because there's a 2 in that, all over 2 times 7 for 14. There's a 2 in every single one of these terms. So we're going to cancel it everywhere. So we're going to have, let's see, 8 minus 2 square root of 2 left, plus 2 square root of 6, minus the square root of 3, all over 7, which is answer B. And the reason it's answer B and not answer D is because 16 divided by 2, 4 divided by 2, 2 divided by 2, 4 divided by 2, and 14 divided by 2. So do not forget to check to simplify when you have some radicals right here on the number on the outside. And we did this back in Unit 5. I think it was 5.3. Don't 100% quote me on that. But we've definitely done this before. This would be a problem that even with a little review, it should help us out. The hard part here is going to be distributing to each and every part of this. And then, of course, there's some simplifying stuff that you got to worry about. Okay, let's look at number 30. So, 29B. Number 30 is the last one I'm going to have us do for today. Rewrite this expression in simplest form. Assume the variables represent positive numbers. Oops, there it is. So, number 30, we're going to simplify. So, I'm going to break this down into things we can take the square root of. So, 16 we can take the square root of. W squared we can take the square root of. We cannot, however, take the square root of y to the third. Can't do it. We're going to have y's left over. We can take the square root of y to the second times y, though. Take the square root of y to the second. Leave the y on the inside. 75, can't take the square root of. So let's write that as 25 times 3. X to the fifth, can't take the square root of for the same reasoning up here. So let's bump it down to x to the fourth times x. So, when we take the square root of 16, we're going to get 4. The square root of w squared, w. The square root of y squared, y. Cannot take the square root of y, so we'll have things left on the inside. Okay, numerator, numerator. Denominator, the square root of 25, 5. Cannot take the square root of 3, so it stays on the inside. The square root of x to the fourth will multiply by itself to be x to the fourth. Well, let's see, x squared times x squared is x to the fourth. So x squared goes on the outside. Cannot take the square root of x, so it's going to stay on the inside. So let's look for the answer. So we're looking for something that looks like this. Nope. Nope. Well, kind of, but not really. This says the square root of everything on the inside. Nope and nope. So it looks like that these square roots don't have a denominator in the square root. So if I want to get rid of dividing by 3x, I'm going to multiply by 3x in both the numerator and the denominator. Same thing on top and bottom. We'll keep it the same. So we get 4wy over 5x squared, and then square root of 3xy over, let's see, 3 times 3 is 9, x times x is x squared. And now I can take care of the square root, because 3 times 3 gives us 9, we can take the square root of 9. Woohoo! We can take the square root of x squared. Woohoo! It'll all work. So the square root of 9 is 3, so we get 5 times 3, x squared. The square root of x squared is x, and that says there's nothing left in the denominator down here, so we get 4wy square root of 3xy. So now let's look for something that has 3xy on the inside, which is A or B or C, but not D, because no, not C. I'm sorry. We can still keep D maybe. Maybe this one. But this one has a y and not y squared, so we can cross that one off. This one doesn't have anything on the outside, so it has to be this one. And more than that, 5 times 3 is 15. X squared times x is x to the third. So it says we're looking at B right there. Okay, so we just did problems numbered. Well, let's go back and check on this. Numbered 25, which is 8.3, 26, which is 9.2, 27 and 28 are trig. You'll do those in pre-cal if you get the pre-cal. Number 29, we totally did that one, so that should be one that we should get right. It's a hard one, but we totally did something like that. And then number 30 is also something we did, and this one's back in Unit 3. And so we should get something like that right. Okay, hold on to your papers. We are going to talk about these some more to make sure that everybody really knows what's going on with these, and then we'll move on with the rest of our stuff.